Welcome back to the Explainer, everyone. Now, for all the data scientists and ML engineers tuning in, look, you already know exactly how chaotic the last 2 weeks have been, right? I mean, we've seen just massive technical shifts across the board. So to actually make sense of it all today, we're going to use a funnel framework. We'll start wide, looking at the macro environment, and then we'll aggressively filter down. We're talking the algorithmic engine room, systems engineering, agentic architectures, and finally, right down to novel, real-world applications.
But before we do any of that, I really want to hook your attention with this number, 500x. And no, this isn't some minor optimization tweak. This actually represents DeepSeek V4's cost advantage in formal theorem proving. They're using a new agent framework called Goedel-Architect, which was developed by researchers over at Princeton. Literally 500 times more cost-effective than existing systems. For those of us who obsess over tracking compute costs and reasoning capabilities, this is a massive leap in efficiency. It honestly changes the entire math on what we can practically deploy at scale.
Okay, so let's dive into this and just quickly walk through our agenda to give you a mental roadmap. First, we'll hit the macro AI landscape, then move into foundation model breakthroughs, tackle optimizing inference and memory, look at the agentic AI evolution, and then wrap the whole thing up with novel applied machine learning. It's a completely packed explainer, so let's just get right to it. All right, starting at the top of the funnel, Section 1, the macro AI landscape. So looking at the Stanford AI Index 2026 report, the data highlights this widening gap between what AI can actually do and how prepared the world is to govern it. But you know what stands out the most? It's the stark contrast in international public sentiment. We're seeing a very clear, highly measurable divergence between American and Chinese public excitement when it comes to AI adoption. And as data scientists who are building products for global user bases, understanding these really distinct regional sentiments, that's absolutely crucial context for your deployment and adoption curves. And speaking of the global landscape, this recent funding news perfectly captures the current dynamic. DeepSeek, who, remember, was previously the last major AI lab still operating without external capital, just raised roughly $6.9 billion US. That puts them at up to a $55 billion valuation. This is a massive maturation for their lab. Meanwhile, over in the US, major players like Anthropic are actively navigating increased government scrutiny and regulatory evaluation. It's just a fascinating contrast, really, watching how the global ecosystem is developing, balancing these massive capital influxes on one side with emerging governance on the other.
Okay, moving on to Section 2, Foundation Model Breakthroughs. If we look at the current state of the leaderboard, wow, StepFund's Step 3.7 Flash is absolutely dominating the artificial analysis benchmark right now. It's taking first place in speed, cost efficiency, and overall end-to-end performance. At the same time, Alibaba's Qwen 3.7 Max is aggressively challenging Google for that coveted third-place spot. And of course, OpenAI's GPT 5.4 continues to make massive splashes in the ecosystem. The main takeaway here, the performance gap between open weights and proprietary models is shrinking way faster than most people predicted.
Now, the absolutely crucial point here is how incredibly fast the open source community is adapting to these massive releases. Look at this quote. The exact moment DeepSeek V4 dropped, it was accompanied by day zero support. The SGLang and Miles teams delivered the very first open source stack to immediately serve and train the model. That means unified FP8 support for mixture of experts reinforcement learning was available instantly. For your daily ML pipelines, this is a total game changer. You aren't waiting weeks to experiment with state-of-the-art architectures anymore. The deployment tools are arriving on the exact same day. Let's filter down a bit further into Section 3, Optimizing Inference and Memory. Let's talk about look-ahead decoding. Autoregressive decoding has, let's face it, always been a sequential nightmare for inference speeds. But look-ahead decoding? It's an exact parallel algorithm that completely breaks this sequential dependency. And we're seeing this put into practice beautifully right now. Tools like Eagle 3 over on Vertex AI are utilizing this exact concept. They're adding a tiny draft head, we're talking just 2 to 5% of the target model size, to dramatically boost speculative decoding, all without needing a massive separate draft model. To put that into perspective, legacy sequential decoding means waiting for token n to generate before you can even think about token n+1. It's just a massive compute bottleneck. But parallel look-ahead decoding frees up those inference pipelines entirely, processing multiple potential token paths simultaneously. It's honestly just a pure hardware utilization win.
And hey, we can't really talk about inference without talking about the KV cache, right? Enter KVAR Qwen, which stands for Variance Normalized KV Cache Quantization. We all know memory constraints are the absolute enemy of long context reasoning, while KVAR Qwen is a total game changer because it's a calibration-free quantizer. It uses hair mod rotation to smooth out outlier features and dual scaling to squash the error accumulation that normally destroys reasoning tasks when you compress the cache. So you get to shrink your memory footprint without sacrificing an ounce of the model's logical coherence. Huge win.
All right, next up, Section 4, the Agentic AI Evolution. So to make agents work autonomously over long horizons, you absolutely need reliable memory frameworks. Recently, we've seen 3 major architectural approaches emerge to tackle this. First, Tokenomizer tackles session memory using graph structures. Then you have Mem0, which focuses on extracting and consolidating long-term conversations. But Memo-Tanto is particularly fascinating to me. It utilizes typed semantic memory combined with an information theoretic retrieval engine. Why does this actually matter for you? Because Memo-Tanto eliminates the computational overhead of hybrid graph architectures entirely. This prevents the context degradation that usually causes agents to hallucinate or get stuck in loops on long tasks.
And how exactly do these agents learn to use new tools? Well, Microsoft Research just dropped SkillOpt. It's a systematic text-based optimizer that actually treats agent skills as an external state. This means the agent can learn and refine its execution strategy over time to achieve superior performance across benchmarks. But wait, here is the absolute best part. It does all of this with zero deployment inference overhead, meaning you get a much smarter agent without paying any latency tax in production. It doesn't get much better than that.
Finally, let's hit the bottom of the funnel. Section 5, Novel Applied Machine Learning. Molecule Mind, which was founded by AI protein folding pioneer Zhu Jinbo, brilliantly illustrates what's possible here with their newly released design pipeline. Check this out. You input targeted protein parameters, the AI executes de novo biologics design, and they are reporting an over 90% success rate in designing novel nanobodies. 90%. We are literally moving from just predicting protein structures to reliably inventing entirely new biological components on demand. Over in the realm of simulation, researchers at Peking University just unveiled EvoPhys-World. And guys, this isn't just basic text-to-video. This is the world's first human-centric, fully controllable 5D world model. It is completely pushing the boundaries of what's possible in autonomous driving and robotic simulation. And notably, this entire system is built and running on domestically produced Chinese computing infrastructure from More Threads, which shows some truly massive strides in hardware-software co-design. Meanwhile, Meta has been incredibly busy in the computer vision space. They just announced SAM 3.1, the Segment Anything model. They've added real-time video multiplexing capabilities and global reasoning. When you pair that with their Dino V2 model, the ability to rapidly detect, segment, and track objects across complex video streams, it's just become vastly faster and way more accessible for developers like us.
And we aren't just talking about benchmark scores here. These vision models are being deployed right now in the real world. At the University of Pennsylvania, they're using Dino and SAM to automate essential medical triage and emergency response. Zooming out to a global scale, Meta actually partnered with the World Resources Institute to release Canopy Height Maps V2 for world-scale forestry mapping. And locally, the UK government is utilizing these exact same Dino models to manage their green spaces and drastically reduce operational costs. It's real-world impact today.
Which brings us to the ultimate takeaway from the past 14 days. We are actively solving the major inference bottlenecks. Our agents are maintaining long-horizon memory and learning new skills without that latency overhead, and we're literally simulating physical worlds and designing new proteins from scratch. So the question I want to leave you with is this. With the infrastructure finally falling into place and agents acting autonomously, what will your models build tomorrow? Thank you so much for joining me on this explainer. Keep building, and I'll see you next time.